Hello, Pre-AP Pre-Calc students. This is Mr. Bear, and I'm bringing you Skill 25. We're going to talk today about linear relationships. To do this, we're going to do an investigation thinking about one of my favorite ice cream places, Cold Stone Creamery. Cold Stone Creamery is an ice cream store that makes handmade ice cream and mixes in your choice of toppings on a frozen granite stone. Cold Stone ice cream comes in 3 sizes. You've got the like it, the love it, and the gotta have it. And if you've ever been to Cold Stone, you know it's good stuff. All right. So below are the prices for a love it size 1 topping ice cream order and a love it 3 topping ice cream order. So if you get a love it size with 1 topping, you're going to spend $4.79. If you get a love it with 3 toppings, as you can see here, we got chocolate chips, Kit Kat, and M&Ms. You're gonna get, or it's gonna cost you $6.57. All right, so the first question is going to be, what is the price per topping? Okay. All right, so let's take a look here. First of all, we have 2 separate prices. We have the price for 1 topping and the price for 3 toppings. If I subtract those, that'll give me the difference in the prices for the 3 toppings and the 1 topping. And if we look at the number of toppings, there were 3 on the $6.57 one and 1 on the 1 topping, the $4.79 one. If I subtract these, if I take $6.57 minus $4.79, I'm going to get a $1.78 increase for every 3 minus 1, which is 2 toppings. 178 divided by 2 is 89 cents. So each topping costs 89 cents. Okay? So 89 cents for each topping. Okay? All right, not too bad. Essentially, when you look at this, we just literally calculated slope. Okay, so we thought of each of these ordered pairs as number of toppings. That's the input, and the output is going to be the cost. And if we think about the 1 topping, you had 1 comma $4.79. And for the 3 topping ones, it was $6.57. Okay, so we just essentially found the slope between those 2 ordered pairs. Okay, how much would you expect to pay for a love it size bowl of ice cream with no toppings? Well, we know 1 topping is 89 cents. When we had 1 topping, it was $4.79. If we subtract off 89 cents, meaning, whoops, not sure where I'm getting the 0.08. If I subtract those, we're going to get that just a bowl of ice cream is $3.70. So this is price with 1 topping, and this is price of a topping. Okay. And so $3.70 is the price with no toppings. Okay. All right, so let's write an equation for the cost of a love it size ice cream with a given number of toppings and then graph it. Okay, so if we look here, our slope is going to be what's changing. So if we look here, our independent variable is the number of toppings. Your price depends on the number of toppings. So when toppings equals 0, the cost was $3.70. So that's going to be like our y-intercept. Okay, and we know from what we calculated up in the first problem here, part A, the slope, so slope, which is the rate of change per topping, is 89 cents. So the way we're going to write this equation is y equals 0.89x plus, oops, that looks like I wrote $370. Sorry, plus 3.70. That's our equation. So what we're going to do is we are going to graph this. So $3.70, that's probably about right here. And then when we add one topping, we're going to go up 89 cents. So let's see, 370 plus 89 cents is going to be about 459. So probably about right there. And you can see that we would have this linear relationship here between the number of toppings, which is your x-axis, and the price, which is your y-axis. And that's how we'd graph this. Okay. All right, a Gotta Have It size ice cream with 4 toppings costs $8.06. Assuming the price per topping is the same for all sizes, what is the price of a Gotta Have It ice cream with 5 toppings and then 7 toppings? Let's start with 5 toppings. So we know the base price with 4 toppings is $8.06. So if I look at that, we have 4 toppings. We know that the price of a topping is 89 cents. All right. So if I have 4 toppings is 806, but we're going to get a 5th topping because it says the cost of 5 toppings. We're going to add 89 cents to that. And that'll give me a cost of $8.95. That's with 5 toppings. Now, if I have 7 toppings, we know we've got 4 from the 806. So we're going to add 3 groups of 89 cents to that. So going ahead and working that out, you would take your 3 times 89 cents and then add $8.06 to that. You should end up getting $10.73. That's a lot of toppings for an ice cream anyway. Okay. Notice how on each of these we took the thing that we multiplied by here. On the first one, it's like I multiplied by 1 because we had our 4 toppings already. I had to add an additional topping to make the 5 toppings. If I look here, I had to add 3 because I had 4 already, but to make 7, I had to add 3 more. All right, so if I wanted to write an equation for finding any number of toppings that doesn't require us to know the base price, what we would do is we would take $8.06, that's the cost of 4 toppings, plus we take whatever number of toppings minus 4, because remember they're giving us the price with 4 toppings, and then multiply that by 89 cents, and that'll equal the price. Okay. If you look here, this is similar to our point slope form. Okay, where you have a slope right here, and you have, this is the base price for 4 toppings on the Gotta Have It size, and then this 4 right here is the fact that when we have a cost of $8.06, you had 4 toppings. Okay, so this part right here is number of additional toppings. Okay. All right, so now that we've explored that, let's put these ideas into some important pieces here. The first thing you need to know is that linear relationships have a constant rate of change. That's also known as a slope. Well, I'm defining that in the next line, so we'll write that there. Rate of change is slope, which is the same as the change in y divided by the change of x. So when you see that little triangle symbol, they use that a lot in physics to mean change of. It's the delta. So when you see that, that just means change in price. So it means you would subtract. Okay. Now notice when we refer to slope, we would say for every whatever's on top. So for every 89 cents that you increase, you're going to get for each additional topping in the case of what we were looking at. All right, so point slope form, your slope is, of course, the m. And x1, y1 is any point on the line. Okay, so your point slope form takes on two forms. So it could be y minus y1, which is the y coordinate of that point, equals your slope times x minus x1, where x1 is the x coordinate of that point. Or sometimes you might have the y over here solved for, so you would add the y1 to both sides, so it'd be y1 plus m times quantity x minus x1. And when you look at the example that we did with the Cold Stone Gotta Have It size, we actually use the second version of the point slope form. Okay? All right, so let's do a couple of check for understandings. So let's say, I'm going to switch color here. Let's say the cost of renting a U-Haul in Chicago is given by C equals $19.95 plus $1.49 times M, where M represents the number of miles driven. What does 19.95 represent in the context of this problem? You would say for each additional mile driven, the cost increases by $1.49. Okay? And what does the, oh shoot, sorry, I interpreted the slope instead of the y-intercept. I am so sorry, friends. You might have been thinking, Mr. Bear, you're on something. I'm going to take what I had there and write it here. So for each additional mile driven, the cost increases by $1.49. That's actually what the slope represents, okay? Now, the 1995 is saying if 0 miles are driven, the base price for a truck for U-Haul is $19.95. Okay? So just to get the truck, it costs you $19.95, and then for each additional mile driven, you're going to increase the cost by $1.49. Okay? All right, let's try writing an equation of a line here. So if I look here, they give us 2 points on the line. So the first thing we want to do is find the slope between them. So we're going to find the change in the y. So it's going to be -5 minus 2. And the change in the x's, 9 minus -7. And that's going to give me -7 over 16. Now we're going to use a point slope form. So y minus, we got to decide on a point here. It really doesn't matter. I'll just choose the top one. So y minus 2 equals -7/16 times x minus -7, which we know we can rewrite that as x plus 7. This is, of course, the point slope form, okay, and it just says write an equation. If I wanted you to write it in slope-intercept form, you would just solve this for y, okay? The next one, a wedding venue charges a flat fee of $900 and an additional fee of $35 per guest attending. So write an equation that models the situation, and if a couple has a budget of $5,000, how many guests can they invite? All right, so it looks like per guest, that's what's changing. So G is going to be guest, and we'll let C equal cost. So let's see, we would have cost is equal to, you have your flat fee of $900, and then you're going to add $35 per guest. We have a budget of $5,000, so we put in $5,000 for the cost, and we're going to solve this for G. So that's going to give us 4,100 divided by 35, and X is going to be, let's see, I'm going to use less than or equal to because we have a budget of 5,000. So actually, we get on the calculator 117.143. So about 117 rather guests can attend. Okay. I don't know if that's a lot or a little. It just depends on your thoughts. All right, last one here, and then I'm going to stop talking. It says in 2013, Netflix reported sales of $4.37 billion, and in 2016, the value increased to $8.83 billion. Assuming the growth is linear, estimate the total sales in 2015 and the projected sales for 2020. Which estimate do you think is likely to be more accurate? Explain your reasoning. Okay, so I'm going to think of this as, so let's think about this. So we have the ordered pair 2013, 4.37, and I'll assume that that number's in billions. And we have in 2016, it was 8.83 billion. So I'm going to interpret those scenarios as ordered pairs. And so now what I'm going to do is find the slope between them. So if I take 8.83 minus 4.37 and divide it by 2016 minus 2013. Let's go ahead and do that on our calculator real quick. So 8.83 minus 4.37 gives us $4.46. Sorry, $4.46 billion. That was over a 3-year span. So it looks like about 1.487, and that's going to be $1 billion per year. That's the rate of change. Okay. If I use that to predict 2015, so if I'm looking at 2015, we take our 8.83 minus 1.487, because remember 8.83 is our 2016, so I subtract off one group of the rate of change to get to 2015. That's going to give me $7.34 billion. Okay. So in 2015, it was about 7.34 billion. Now let's look at projection for 2020, even though now we know it's past 2020. 2016 is our year of reference, so we're going to go up 4 years from that. So we're going to have 8.83 plus 4 groups of that slope of 1.487. And that'll give us $14.78 billion. All right, if we look here, which do we think is more accurate? I would say 2015 is more accurate because it's within the data set given. All right, 2020 at that point is far in the future. We don't know what's going to happen with Netflix, although I bet this problem was written before a pandemic happened, so a lot of people actually did end up subscribing to Netflix. But anyway, 2015 would be more accurate because that data value is within the range of the data values they gave us. So for instance, we were using 2013 and 2016 as our years. 2015 falls within that range, or I should say that domain. All right, so that's all I got here. Good luck, and let me know how I can support you.